So as we just finished a unit about constructing histograms, constructing and figuring out standard deviation 5-number summaries, we are now going to move into a section where we're going to use technology to do all of the same things that we've done by hand. And the reason we're doing that is because we're going to cease just looking at the data, constructing the data, computing the data, and start analyzing the data. A distribution of data shows the observed or theoretical frequency of each possible data value. So we've talked about histograms already, and sometimes our histograms aren't exactly split down the middle. They are not symmetrical. You have what is called a negatively skewed distribution, and notice that on this histogram that we kind of have a long tail on the left side. So it kind of stair steps up to a tall bar, which is right here, and then it suddenly drops off. So since the tail is on the left side, and the left side is normally where you have negative numbers, we would simply say that has a negatively skewed distribution. Sometimes you might hear me say it is skewed left. That's kind of a term that I got during my college days, and I'm likely to continue to use that. So skewed left, negatively skewed distribution mean the same thing. See, the one in the middle here is called a symmetric distribution, and notice that the tall bar right here is right in the middle or near the middle, and how it has the same size bars on the left side, and then further down each side has roughly the same size bars. So we call that a negative distribution, or excuse me, a symmetric distribution. And then you can see on the right side, you have a positively skewed distribution where you have the tail on the right side. So it kind of increases very quickly on the left side to a tall bar, which is on the left side of the distribution, and then it stair steps down to the right to form that tail. So that is a positively skewed distribution, and sometimes you might hear me say that the data is skewed to the right. Again, that comes from my college days, a term that we often used then. So like I said, we're going to start using technology, and you can use your devices to construct histograms. So even though the directions say to use a graphing calculator, we instead are going to use a couple of tools that I have in your Google Classroom already. So if you go to your Google Classroom, you can see that I have two attachments there. One of those attachments is the Easy Histogram Maker, and one of them is called the Box Plot. So right now, the first problem that we have says to use a graphing calculator to construct a histogram, so we're going to use the Easy Histogram Maker. So I'll open that up. And you can see that there's a box here on the left side that you're going to type in all of your numbers. And instead of using commas, the best way I've discovered to do it is just to hit enter and make a single row of numbers. So the data we have, and if you have your textbook, it's on page 673. The data we have on example 1, which I do also have written here. So if you're following along, you can pause the video and look at example 1 and type in the data into the histogram maker. And you can see here through the magic of editing, I've already typed in all of the data, a very long list of data. So I'm going to click generate, and voila, we have our histogram that is already created for you. So what I like to do on these is to check out some different intervals. So notice that the interval of the histogram goes from 18 to 23, then one bar goes from 23 to 28, and 28 to 33, creating 6 bars. I'd like to create more bars to see if it changes the data, because this looks like it was probably positively skewed since we do have a tail to the right and the tall bar is off to the left. If I go down here with this histogram maker, I can change the number of classes. So let's see what happens when I change the number of classes to 7. So I'll edit the histogram when I do that. And you can still see the tall bar is off to the left, and it kind of tails off to the right with 7 bars. And I could just do that with a few things. Now I have a tendency to like going with odd numbers, because with an odd number, if the tall bar is in the exact middle, then I can say it's probably going to be asymmetrical data. So I'll do a 5-bar one, and you can still see even with a 5-bar one that it is got the tall bars to the left and it tails off to the right. So the way I would answer the question after looking at the histogram on my data, to describe the shape of the histogram, since it is tailing off to the right, I would say that this is either skewed right or just simply positively skewed. We can do this one as well. Use a graphing calculator to construct a histogram of the data and use it to describe the shape of the distribution. So I will go back to the Easy Histogram Maker, and I'm going to delete my data. And so I think the best way to do that is just to go back to our data. I'll have to go back a few screens. So again, I've typed those data numbers in already. So I'll click Generate to generate my histogram. And this one automatically split it up into 5 bars. And again, I'll go through and try to do some other classes. So if I do a 7-class histogram, I still got that tall bar that's right in the middle. It is a little bit taller on the left side of the bars than the right side bars, but I really like that tall bar in the middle, especially the 7s that are on either side of it. Let's do a 9-class one. And again, it does have kind of a weird drop-off, but the tall bar is still in the middle. So I would safely say with that tall bar right set in the middle that this is going to be symmetric distribution. I can spell it correctly. Because of that tall bar in the middle. Some other things to point out about the histogram generator. If I can find it again. There it is. So off to the left side, it does some of the things that we're also going to talk about. It automatically computes the mean, the standard deviation. It's got the low score, the high score. It's got a lot of the measures of spread that we're going to talk about. We've already talked about and constructed by hand that we're going to do this section as well. A box and whisker plot can also be used to identify the shape of a distribution. So recall that box and whisker plots are used to visually show a 5-number summary. So in this particular box and whisker plot, the point at the far left represents the minimum. The end of this point right here represents the quartile, the lower quartile, or Q1. The center is actually the median, which is the Q2. This is going to be the upper quartile, Q3, and then the far right point is the maximum. So all of that is shown and described in a 5-number summary. Notice that if you have a longer whisker and a longer box on the left side, as we do over here, we have a negatively skewed distribution. If the box and whiskers are roughly the same size, it will be a symmetric distribution. And if you have a longer box and a longer whisker on the right side, then it is a positively skewed distribution, much like we have positively, negatively, and symmetric distributions that can be seen with a histogram. So we can also use a box and whisker plot to describe data. So use a graphing calculator to construct a box and whisker plot of the data and use it to determine the shape of the distribution. So we will go to our box and whisker plot. You can find the box plot generator on Google Classroom, and when you click on that link, you'll bring up to this screen. It's at alcula.com, and we are going to type in the example 2 data list into that box plot calculator. So after I type in the data list, I'll just click Submit Data. And you can see that this box plot generator actually creates a horizontal box plot, or excuse me, vertical box plot, where the higher numbers are at the top and the lower numbers are at the bottom. So you tilt your head or turn your laptop sideways if you need to see it horizontally. But notice that the boxes and the whiskers are all roughly the same size, so this is symmetric data. It does have one outlier, but the rest of the plot definitely looks symmetric, so I would describe this as a symmetric distribution. We can also look at example number 2, use a graphing calculator to construct the box plot whisker for the data that is down below, and I'm talking about this part down here. So let's go ahead and create a box plot using that data. So go back to your box and whisker plot generator, and we will reset it to create a new one, and then we will type in that data. So I've already typed those in, and then I submit my data. And you can see that here's the box and whisker plot for this one, and the box and the whisker on the bottom of the graph is much larger than the box and whisker at the top. So this would be a negatively skewed distribution. Again, the box and whisker being larger on the bottom means that it is favoring the smaller numbers, and that would be the result of a negatively skewed distribution.